A very good evening to one and all. So in this lecture, we are going to describe about the pumps. So we already discussed about the turbines. Now in this lecture, we are going to discuss about the pumps. So before starting, I can tell you that there are two broad categories of turbo machinery, that is pumps and turbines. Now, how you hear about the term pump? Yes, of course, you may be. The word pump is a general term for any fluid machine that adds energy to a fluid. Some people call pumps as energy absorbing devices. Why? Since energy is supplied to them and they transfer most of that energy to the fluid, usually via a rotating shaft. The increase in the energy, that is the fluid energy, is usually felt as an increase in the pressure of the fluid. So we already learned about the turbines, isn't it? So what we can call them? So on the other hand, the turbines are energy producing devices, isn't it? Because they extract energy from a fluid and transfer most of that energy to some form of mechanical energy output, typically in the form of a rotating shaft. So let's start this lecture. So we can call this pumps as an energy absorbing devices, or I can call it as a mechanical device used to increase the pressure energy of a fluid or a liquid. So how can you achieve this? So it can be achieved by creating a low pressure at the inlet and high pressure at the outlet of the pump, isn't it? You know that in most of the applications, the pump is used for lifting a liquid from a low level to a higher position or a higher level. So how this is achieved by creating low pressure at the inlet and high pressure at the outlet of the pump. So the pumps can be generally classified into two types: positive displacement pumps and rotodynamic pumps. So this classification is based on the working principle. There is a positive displacement pumps and rotodynamic pumps. For example, the reciprocating pump, gear pump, screw pump, vane pump are the examples of positive displacement pumps, whereas the centrifugal pump, propeller pump, etc. are examples of rotodynamic pumps. Again, based on the number of stages in which the pressure of the liquid energy is increased, as I told you earlier. So the prime function of the pump, as they are energy absorbing devices, add energy. So this energy addition can be done in number of stages, based on which the rotodynamic pumps are again classified into single stage and multi-stage pumps. Now, first one would be we are going to discuss about the reciprocating pump. So the reciprocating pump, it is a positive displacement pump. I will call it as a positive displacement pump. Why? Because the required low pressure at the inlet and required high pressure at the outlet of the pump. So that is one of the requirement of a pump, isn't it? You need a low pressure at the inlet and high pressure at the inlet. Because of the low pressure at the inlet of the pump, the liquid is lifted from the source or the sump to the pump. And due to the high pressure at the outlet of the pump, the liquid is lifted from pump to the required height. So the for any pump, the requirement would be something like that. They required low pressure at the inlet and required high pressure at the outlet. And this is obtained by the reciprocating motion of the piston or plunger inside a cylinder. So that is called a reciprocating pump. So it's a positive displacement pump in which the required low pressure at the inlet and required high pressure at the outlet of the pump is obtained by the reciprocating motion of the piston in a close fitting cylinder. So if you look at the what is shown here in this slide is a schematic diagram of a reciprocating pump. You can see what are the different parts. If you look at the diagram, you can see a cylinder, you can see a piston rod is marked, a connecting rod you can see, a crank you can see, a strainer maybe which is actually at the bottom, which is not marked here, a suction pipe you can see, suction valve, a delivery pipe and a delivery valve you can see. Now let's see how does it work. You can see that of course this piston will be having two types of movements, maybe towards right and towards left. That are the two movement possible, isn't it? The movement of piston towards right, when the piston moves towards right, it creates vacuum inside the cylinder, and because of the atmospheric pressure or the atmospheric pressure forces the liquid from the sump up through the suction pipe into the cylinder. And on the backward movement or the during the movement of the piston towards the left, this liquid which is in the cylinder is pushed into the delivery pipe. If you look at the diagram, you can see the suction and delivery pipes are fitted with the non-return valves, where the suction valve and delivery valve are non-return valve. What does it mean? The non-return valve is a one-way valve. So it always ensures unidirectional flow of the liquid, no backward flow. So thus the suction valve allows the liquid only to enter into the cylinder, and it prevents the liquid from the cylinder to the suction pipe. It will not go back. Similarly, the delivery valve also. It allows the liquid only in the from the cylinder to the discharge or the delivery pipe, and it prevents the flow of liquid backward. And how this movement of the piston inside the cylinder is obtained? If you look at the diagram, you can easily see that a connecting rod, you can see that a piston rod is connected to the crank by means of a connecting rod, and because of this it creates the movement of the piston inside the cylinder. You can see that the crank is rotated, and this crank is rotated using an electric motor, and as a result when the crank rotates, the piston reciprocate inside the cylinder, and when the piston reciprocate, it creates the filling and emptying of the cylinder. So this is how a reciprocating pump works. And there is another part which is actually not shown in this figure, a strainer, which is usually provided at the end of the suction pipe. So when you pump the liquid from the sump to the cylinder, in order to filter sometimes some leaves, some wooden pieces, or some other test materials, in order to filter it, a strainer is usually provided at the end of the suction pipe. And this is how a reciprocating pump works. Now, next what we are going to learn about is a centrifugal pump. Maybe this term you are more familiar with, isn't it? It's an example of a rotodynamic pump. So in which here in earlier case I told you the reciprocating pump was a positive displacement pump. So this is a rotodynamic pump. And here the required low pressure at the inlet and high pressure at the outlet is obtained mainly due to the centrifugal action. I think most of you are familiar with the centrifugal force. What do you mean by a centrifugal action? In your schoolings or maybe during your higher secondary education, you are familiar with this. What do you mean by a centrifugal force? What do you mean by a centripetal force? What was that? For example, when a mass of liquid is allowed to rotate by an external force, it is thrown away from the axis of rotation and a centrifugal head is obtained which enabled the liquid to rise to a higher level. So that is how things works here. Okay, which means in centrifugal pumps, in the case of centrifugal pumps, so this because of this centrifugal head which is the centrifugal head which enables the liquid to rise to a higher level. So in addition to the centrifugal action, as the liquid passes through, while we are going to discuss about the structure of this pump, we are going to see uh, an impeller. So it's a revolving wheel, and when this liquid passes through the impeller, the angular momentum of the liquid changes, which also results in increasing the pressure energy of the liquid. So that is the centrifugal pump is a rotodynamic pump in which the required low pressure at the inlet and high pressure at the outlet is obtained by the centrifugal action. So these are the two factors which contributes to the increase in pressure energy of the liquid. One is centrifugal action, and second one would be a change in angular momentum when the liquid is passes through the revolving wheel or the impeller. So if you the schematic diagram of centrifugal pump is shown on the right side of the slide. You can see there is an impeller at the center, a casing which covers this impeller, a delivery pipe you can see, a suction pipe, a foot valve, and a strainer. So these are the main components of a centrifugal pump. So what do you mean by an impeller? It's a wheel or a rotor which is provided with a number of curved blades, or it is also known as vanes. Blades or vanes are the nomenclature of the um, is imposed to it. So this impeller which is mounted on a shaft which is coupled to an electric motor. So then another part is a casing. So it's a airtight chamber which actually covers the impeller. The shape of the casing, if you look at the diagram, you can see that it is such that the cross-sectional area of flow around the periphery of the impeller gradually increases towards the delivery pipe, isn't it? You can clearly see it from the diagram. So this increase in area, this gradual increase in area reduces the velocity of the liquid leaving the impeller. That is to the leaving the impeller to the delivery pipe. So this reduction in if the velocity decreases, of course, half mv square, the kinetic energy of the liquid while passing through the casing increases. That which means the kinetic energy is converted into useful pressure energy. If you look at this diagram again, you can see that the suction pipe, which actually connects the center of the impeller to the sump, and the lower part of the suction pipe is fitted with a foot valve and a strainer, and the delivery pipe which connects the outlet of the pump to the delivery point, So this is how it looks like, isn't it? Now let's see how does it work. So one of the very important operation, maybe some of, so this actually this centrifugal pump is a pump which you have use, most of you use it in your domestic purposes, especially in your homes, to pump the water from your well to the tank. Maybe you may be familiar with this operation, priming. Maybe you may not be familiar with the term, but you have done this. Let's see what is meant by priming. Actually, this priming is the purpose of priming is to remove the air and vacuum from the suction pipe and casing. So to remove the air and vacuum from the suction pipe and casing. Why it is required? Because the vacuum created in the impeller is proportional to the density of the liquid that is in contact with the impeller. So as a result, the priming is very important. See if the air or if you need to remove the air, you need to remove the air from the casing. So this actually this filling of the suction pipe and casing with the liquid to be pumped is known as the priming. The filling of the suction pipe and casing with the liquid to be pumped is known as the priming. Not only water, sometimes some kind of oils are pumped using this kind of pumps. So the first of all, that is the first step, filling the suction pipe and casing with the liquid to be pumped. If it is water, you that is, so that's called the priming. Now, um, what will happen if the impeller is made to rotate in the presence of air? What will happen is the vacuum created may not be sufficient to lift the water from the sump to the impeller. So that is what we are doing the priming. Maybe you may expect this as a 2 mark or 4 mark question. Why the priming is required? So, so it is very important to prime a centrifugal pump. So in order to remove the air and vapor from the suction pipe and casing. So what I written here is wrong. Like to remove the air and vacuum. To, what I try to write is to remove the air and vapor from the suction pipe and casing. Okay. Now, so the let's see how does it work. Now, when the impeller rotates, the rotation of the impeller in the casing is of course the casing once the liquid from the sump to impeller the liquid is pumped. Of course, you know the impeller is full of liquid. So the rotation of the impeller in the casing, which is full of liquid, produces a forced vortex, and which imparts a centrifugal head to the liquid or increases the pressure energy of the liquid. Yes, of course, this increases the pressure energy of the uh, pressure of the liquid in the impeller. So when the delivery valve is opened, the liquid from the impeller flows in an outward direction, that is leaving the veins of the impeller at the outer circumference with high velocity and pressure. So the vacuum which is created at the impeller causes the liquid from the sump to rush through the suction pipe, replacing the liquid which is being discharged from the impeller. So while the liquid flows through the rotating impeller, it receives energy from the veins, which results in increase in both pressure and velocity. So the kinetic energy thus converted into pressure energy while flowing through this casing. And finally, the liquid discharges from the pump to the delivery pipe with very high pressure. So these are the points I can, first of all, the rotation of the impeller in the casing produces a forced vortex which imparts centrifugal head to the liquid. And finally, when the delivery valve is opened, the liquid within the impeller flows in an outward direction. And now, please note that the vacuum which is created at the eye of the impeller causes the liquid to be pumped from the sump to the suction pipe. Now, let's see some. Let's compare both centrifugal and reciprocating pumps. And first of all, the first one is centrifugal and the second column is reciprocating pump. So the flow of the liquid from the centrifugal pump is very smooth, whereas in the case of reciprocating pump, which is pulsating in nature. The centrifugal pumps are suitable for large discharge and low head, whereas the reciprocating pump is suitable for high head and low discharge. The initial cost is less for centrifugal pump, whereas it's comparatively more for reciprocating pump. And the centrifugal pump is compact and it occupies less floor space, whereas the reciprocating pump 6 to 8 times that of centrifugal pump. The efficiency of low head centrifugal pump is more, whereas that is low for reciprocating pump. Low head reciprocating pump, the efficiency is low. And for reciprocating pump, for small discharge and high head, the efficiency is more for reciprocating pump, and for small discharge and high head, the efficiency is less for centrifugal pump. You can easily handle the high viscous liquids in the case of centrifugal pump, but the more valves and glands are present in reciprocating pumps, which cause trouble. So installation is comparatively easy in centrifugal pump, whereas it is complicated in reciprocating pump. The maintenance is comparatively low in the case of centrifugal pump, whereas it is complex in the case of reciprocating pump. Why the maintenance is complex? Because more parts are present in the case of reciprocating pump. Thank you.